My dear students of class 9, I am going to start chapter 8 quadrilaterals exercise 8 decimal 2 question number 3. ABCD is a rectangle and PQRS are midpoints of side AB, BC, CD, DA respectively. So that the quadrilateral PQRS is a rhombus. For the solution of this question, we write given ABCD is a rectangle in which PQRS are the midpoints of side AB, BC, CD, DA respectively. To prove PQRS is a rhombus. For this we do construction. We join the diagonals AC and BD. Proof. In triangle DAC, S and R are the midpoints of side DA and DC respectively. Then by the midpoint theorem we get SR parallel to AC, we consider this as equation 1, and SR equals to half of AC, we consider this as equation 2. The statement of midpoint theorem is, in a triangle, the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is equal to half of it. Now, in triangle BAC, P and Q are midpoints of side BA and BC respectively. Therefore, PQ parallel to AC and PQ is half of AC. We consider this as equation 3 and this as equation 4 by midpoint theorem. Now, we compare 1 and 3. So, from 1 and 3, we get SR parallel to PQ. Why? In 1 we see SR parallel to AC and in 3 we observe here PQ parallel to AC. So the lines parallel to the same line are parallel to each other. SR and PQ both are parallel to the same line AC, hence they are parallel according to this property. We consider this as equation 5. Also from 2 and 4. In 2 we see SR is equal to 1 by 2 AC and in 4 we see PQ is equal to 1 by 2 AC. RHS of 2 and 4 are equal because both have 1 by 2 AC, 1 by 2 AC. So LHS of 2 and 4 must be equal. So from 2 and 4 we write SR equals to PQ. We consider this as 6. Now, from 5 and 6 we get quadrilateral PQRS is a parallelogram. Why it is a parallelogram? Because we know that a quadrilateral is a parallelogram if its one pair of opposite sides parallel and equal. Now, by 2 we get SR equals to half of AC. We consider this as equation 7. Similarly, SP is half of BD. This SP is half of BD. But diagonals of rectangle ABCD are equal. AC is the diagonal of rectangle ABCD. Similarly, BD is the another diagonal of rectangle ABCD. But we know that diagonals of rectangle are equal, therefore AC equals to BD. We consider this as equation 9. From 7, 8 and 9 we get SR and SP are equal. We write SR equals to SP. Now, in parallelogram PQRS, the adjacent sides SR and SP are equal. This implies that PQRS is a rhombus. In parallelogram, if adjacent sides are equal, then parallelogram is a rhombus. So finally, we write PQRS is a rhombus. This is the proof of question number 3. This is the answer of question number 3. Now question number 4. ABCD is a trapezium in which AB parallel to DC, BD is a diagonal and E is the midpoint of AD. a line is drawn through E parallel to AB intersecting BC at F. See this figure. Show that F is the midpoint of BC. For the solution of this question, we write given ABCD is a trapezium in which AB parallel to DC is the midpoint of AD and EF parallel to AB. To prove F is the midpoint of BC. Proof. Since AB parallel to DC given, we consider this as equation 1. Also, AB parallel to EF, it is also given. We consider this as 2. From 1 and 2 we get EF parallel to DC. Lines parallel to the same line are parallel to each other. Now, in triangle DAB, EO parallel to AB as EF parallel to AB. Then by the converse of midpoint theorem we get O is the midpoint of DB. A statement of converse theorem is a line through the midpoint of a side of a triangle parallel to the another side bisects the third side. Using this property, we see that we prove that O is the midpoint of DB. We consider this as equation 3. Also, in triangle BDC, O is the midpoint of DB by 3 and OF parallel to DC. Since EF parallel to DC, so OF also parallel to DC. Then by the converse of midpoint theorem, F is the midpoint of BC. This is the proof of question number 4. This is the last question today. I will meet you next day with another set of questions. Thank you very much.